So we have went over the substitution method of integration. Now let's take a look at how do we integrate in if we are given exponential function. So an exponential function can be integrated using the formulas. The integral of e to the x dx equal to the e to the x plus c. The integral of a to the x dx is the same as saying a to the x divided by ln of x plus c. Okay, so let's take a look at the first example. Here we have to do a little substitution. So we have the integral from 0 to 1 of e to the 2t divided by e to the t plus 1 dt. So let's go ahead and let u be equal e to the t plus 1. Then du equal e to the t times dt. Now looking to our integral, we have e to the 2t, right? And we have dt. So let's go ahead and solve for dt. This meant 1 over e to the t du is equal to dt. Now we just said that u equal e to the t plus 1. This means e to the t equal u minus 1. I can then rewrite my integral. Oh, one last thing. So e to the 2t is the same as saying e to the t to the second. So this is the same as saying u minus 1 squared. Now we have everything in our integral. Let's go ahead and rewrite this integral as u minus 1 squared divided by u dt is 1 over e to the t. So that's 1 over u minus 1 times dt. Okay. Now we need to change the upper and lower limit of our integral. So the upper limit, when t equal 1, u equal e to the first plus 1. When t equals 0, u equal e to the 0 plus 1, and that is 2. So our upper and lower limit now become from 2 to e plus 1. Let's go ahead and expand this integral out. 2e plus 1. So we're looking at u. So we can simplify this part, right? We can simplify this. So you have the integral of u minus 1 divided by u times dt. This equal to 2e plus 1. 1 minus 1 over u. Excuse me, this is du, right? Not dt anymore because we already changed it. So this is du. So this is u minus ln of absolute value of u. Evaluate from 2 to e minus 1. Now this becomes e minus 1 minus ln of 2. E minus 1 minus ln of e minus 1 minus 2 minus ln of 2. We can simplify this up. This equals e minus 3 minus e. So e minus 3 minus ln of e minus 1 plus ln of 2. In the next problem, we can go ahead and let u equal 2x to the e times. Let u equal 2 times x to the third. So then du equals 6x dx, 6x squared dx. So then 2 du is equal to, so 1/2 du, I mean. So 1/2 du. So 1/2 du equal 3x squared dx. We can then rewrite our integral as 1/2 e to the u times du. So that is 1/2 e to the u plus c. And this is 1/2 e to the 2 times x to the third plus c, for c is a constant. Now how do we use this kind of problem in application? Suppose the rate of growth of bacteria in a petri dish is given by cube of t equal to 3 to the t, where t is given in hour and cube of t is given in thousand of bacteria per hour. If a culture starts with 10,000 bacteria, you want to find a function qt that gives the number of bacteria in the petri dish at any time t, and how many bacteria are in the dish after 2 hours. So first we need to find a function to calculate the number of bacteria in the dish at any time t. So we first need to find q of t. So q of t is equal to the integral of small q of t dt. So this is the integral of 3 to the t dt. This equal 3 to the t divided by ln of 3 plus c. Now we need to calculate that c. Well, we were told that q of 0 is equal to 10,000. This means 3 to the 0 divided by ln of 3 plus c equal 10,000. This implies c is equal to 9,090. We round it to the whole number. Okay. So remember this said in hour and q of t is given in thousand, right? This meant right here we're supposed to have 10 for 10,000. So the number of bacteria is 9.090. Okay. So after 2 hours, so we calculate q of t. Well, q of t is equal to 3 to the t divided by ln of 3 plus 9.090 at t equal to q of 2 is equal to 17,283. So at t equal to at 2 hours, the number of bacteria in the dish is 17,283. Suppose the population of fruit fly is increased at the rate of g of t equal 2 times e to the 0.02 in flies per day. If the initial population of fruit flies is 100, how many flies are there in the population after 10 days? Again, we first need to calculate capital G of t. So G of t is equal to the integral of 2e to the 0.02 t dt. Okay. So again, this is a simple substitution, right? So go ahead and let u equal e to the 0.02 t du equals 0.02 times e to the 0.02 t dt. Hang on. sorry, my bad. We're supposed to set u equals 0.02t. Okay, that makes more sense. So du equals 0.02 dt. Notice that we have a 2 out front. So then 100 du equal 2 dt. Now this becomes the integral of 100 e to the u du equal 100 e to the u plus c. So g of t equal 100 e to the u plus c. If the initial population of fruit flies is 100, and this t that is so that u should be what, 0.02t. So when g of 0, at g of 0 we have 100 e to the 100 plus c equal 100. So here c equal to 0. Is that right? No, c equal to, that's right, c equal to 0. So g of t, the function, is equal to 100 e to the 0.02t. What is the population of flight after 10 days? Well, after 10 days, g of 10 is equal 100 e to the 0.02 times 10, and that is equal to 122. Let's take a look at the integral that involves logarithmic function. Okay, so the integral of 1 over x dx equal to ln of x plus c. And here we have the integral of ln of x, the integral of log base 8 of x dx. So let's use that to calculate the following. We want to find the integral of ln of x divided by x dx. So let's say we go ahead and start with let u equal to ln of x. So then here du is equal 1 over x dx. Our integral now becomes the integral of u times du, that equal 1 over 2 u squared plus c, that is 1/2 ln of x squared plus c. Let's see in the next one. Here we have an ln of cosine of x times tangent of x dx. So go ahead and let u equal to ln of cosine of x. So du equal 1 over cosine of x times negative sine of x dx. That's equal to du equal to negative tangent of x dx. So negative du equal to tangent of x dx. Our integral now becomes the integral negative of u times du. That is negative 1 over 2 u squared plus c. That is negative 1 over 2 times ln of cosine of x squared plus c.